I'll quickly give you a recap of what we plan to discuss. So, hope you heard of the term expressions. So, there are two kinds of expressions. One is the numerical expression, for example, 3 plus 8. This is a numerical expression. When you have variables, a variable is a letter used to represent one or more numbers. When you have variables in an expression, we call it a algebraic expression. Okay, say for example, 8x minus 5. This is an algebraic expression. Another example would be 7x squared plus 4x minus 10. Another example would be x minus 1 divided by x squared plus 12. I hope you've already encountered these kind of expression in your classes already. Yeah, cool. And you can also have expressions of these kinds. Say, for example, 2x plus 3y, 2x squared plus 3xy plus 4y squared, right? And what do you think will be the difference between these kind of expression and these kind of expressions? Can somebody tell me quickly? What is the difference between these kind of expressions and these kind of expressions? Yeah. The first, these expressions. Yeah, these expressions. Anjali, we are just talking about expressions. Okay, we are not solving for a number. These are just expressions. These are like phrases in English. Okay, this is not an equation yet. You call it an equation when you have an equality sign happening. Okay, for the time being, let's call this an expression, and these are expressions in just one variable. Okay, and the variable being x, right? And these are expressions in two variables. Okay, please understand the difference between an expression in one variable and an expression in two variables, x and y. Got it? I hope this is okay. Yeah, we are not discussing equations yet. We are still talking about expressions. And now, can you tell me what's the difference between this expression and this expression? They both are algebraic expressions, and they both are expressions in one variable. Now, can you tell me the difference between this expression and this expression? Just think, you already encountered these kind of expressions earlier. I just want you to refresh your memory. Please wait. Yes. No, we don't have an exponent yet. It's not called an exponent. I mean, there is an exponent happening, but I'll tell you the difference. See, the first expression, in the first expression, 8x minus 5. Okay, when you look at the power, when you look at the exponent of x, it is 1. Okay, it is 1, right? X is nothing but x to the 1. X is nothing but x to the 1, right? X to the power of 1. And in fact, the 5 can be written as x to the 0, x to the power of 0, right? X to the power of 0. Cool. So in this expression, the first expression we are talking about, in the first expression, the maximum power, maximum exponent of x is 1, right? You have x to the 0, you have x to the 1. And the maximum exponent that is happening is x to the 1. So this is what we call a linear expression. Linear expression. And more specifically, this is a linear expression in one variable x. I hope this is okay. This is what we call a linear expression in one variable x. Because when you look at the power of x, the maximum power you can see in the expression will be x to the power of 1. X raised to 1. Is this all right? Yeah. You can have other examples. For example, 3x plus 5. Okay. So the thing you need to realize that this 5 is nothing but 5x power 0. And when you go to the next expression, 7x squared plus 4x minus 10. What do you observe? You have x to the power of 2, you have x to the power of 1, and in fact, you have x to the power of 0. Right? Yeah. Yeah. So this is what we call a quadratic expression. This is what we call a quadratic expression. Okay. To be more specific, this is what we call a quadratic expression in just one variable x. Got it? We're still discussing expressions, just like algebraic numeric expression. For example, 7 into 5 square plus 4 into 5 minus 10. This is a numerical expression. You know how to evaluate this. So instead of numbers only, we can have numbers, variables, and operations in an algebraic expression. And we can have algebraic expressions in just one variable. We can have algebraic expressions consisting 2 or more variables. And we can have expressions of the form, say, 8x minus 5 or x plus 5 and these kind of things. And this is what we call a linear expression in one variable x. Because, you know, the highest power of x is x power 1. X to the 1, x raised to the power of 1. And here in this case, the highest power that is happening is x power 2. Okay? You should not confuse. Now that you've mentioned exponents, you should not confuse, should not get confused with expressions like 3 power x or 2 power x. Okay, these are different because your variable here appears in the exponent. Okay, your variable here appears in the exponent. You understand the difference, right? Okay. Yeah, and soon later we will see that these expressions are called exponential expressions. Okay, these are exponential ones. Yeah, see, in earlier expression we are talking about 7x squared plus 4x minus 10. Okay, now if you observe, how does the exponent appear? Exponent appear as numbers. Okay, actual numbers. So you have x raised to 2. You have x power 1, and here we have x power 0. Okay. This is in the case of a quadratic. And similarly for a cubic, For a cubic, you can have 7x power 3, say 2x power 2, plus say x power 1, say plus n x power 2. This is what a cubic. Because highest power of x that is happening, that is there in the expression is x power 3. Highest power of x is there in the expression x power 3. Right? Now, when you come to an expression of this form, you can see that x appears in the exponent. See, x is here, x is here. So, what I'm saying is these are totally different stuff. Different stuff compared to these stuff, compared to these kind of expressions, these are totally different expressions. Okay. So we don't have to worry about these kind of expressions for the time being. Let's worry about these kind of expressions for the time being. Robin, is that okay? Here we have combinations of x power 0, x power 1, x square, x cube, etc. Here we have x happening, x appearing on the exponent. Okay, so that's the difference. We don't have to worry about for these for the time being. And to begin our discussion, okay, we will be specifically talking about linear expressions only. For the time being, we are starting with linear expressions because, you know, this heart of algebra topic, I told you 1/3 of the questions will be from this syllabus, from this topic. So in this topic, I told you 1/3 of the syllabus will come from heart of algebra. In this topic, we'll be restricting our discussion only to linear expressions, and slowly we'll move on to linear equations and linear inequalities and that kind of stuff. So linear expression will always look like, when simplified will always look like, say 3x plus 5, 2x plus 3, x plus 2, and this kind of stuff. Right? So that is linear expression for you. Cool. So let's quickly do one problem. And one more thing I want to tell you is, one more thing I want to tell you is, we can also have linear expression more than one variable. We can have more expressions which have more than one variable. Say, for example, see this. What do you think about this expression? What do you think about this expression? This has both x and y. So it's a linear expression in two variables. Why do I call it a linear expression? Why do I call it a linear expression? Yeah, it has two variables. That is about the number of variables. Why do I call it a linear expression? Because when you look at the exponent of x and y, the variables, it's nothing but 1. Right? The maximum exponent that can occur for the variables in this case is 1. Right? You have 2x power 1 plus 3y power 1. So this is basically a linear expression. But just that it has two variables. Is that fine? Is that okay? Yeah. And what about this expression? What about this expression? Can somebody tell me the difference between the first one and second one? Okay, I'll state it more clearly. See, there are two expressions, 2x plus 3y, 2x squared plus 3xy plus 4y squared. Now, can somebody tell me? Yeah. So both of them are expressions in two variables. That is fine, right? Both of them are expressions in two variables. And this is what we call a linear expression in two variables. And this is a quadratic expression. This is a quadratic expression because, you see x power 2, you see y power 2, right? So if you have x power 2 and y power 2, okay, so they are not linear anymore. They are quadratic. Got it? Yeah. So just to summarize what we learned so far, 2 plus 3. This is a numerical expression. Okay. Now 2x plus 3, 5x square plus 4x plus 5. 2x plus 3y, 4x square plus 5x plus 5xy plus 6y square plus 7 plus 8x. This is a numerical expression. These four are algebraic expressions. Okay. Now, this is a linear expression. No, this is an expression in one variable. This is an expression in one variable. This is an expression in two variables. This is an expression in two variables. Yes. Now, more specifically, this is a linear expression in one variable. This is a quadratic expression in one variable. This is a linear expression in two variables. This is a quadratic expression in two variables. So far, so good. Yeah, cool. And as I mentioned, we'll be discussing only about linear expression for the time being. We'll be discussing only about the linear expressions. Okay. So let's do a problem quickly. So this question came in previous SAT. Just try this question. So read the question and tell me the answer. Yes, cool. Okay. Yeah. So one guy is sending out M text messages per hour for 5 hours. So there are 5 times M messages and there are 4P messages. It's basically 5M plus 4P. Okay. And you need to know that you can also write this as 4P plus 5M. These are exactly equal. Okay. So just like for the numerical expressions, you can use the commutative property. You can have commutative property here as well. Okay. You're basically replacing numbers with symbols. Okay. You're basically replacing actual numbers with English letters. So the normal rules of the arithmetics you have already learned, like the commutative property and associative property and things like that, will still hold. All right. Now the thing is, you can always evaluate an expression. Okay, what do you mean by evaluating an expression? Say, for example, you have an expression 4x. What do you think will be the value of this expression at x is equal to 120? Can somebody tell me? What do you think value of this expression at x is equal to 120? No, you're putting x is equal to 120. Okay. Robin, I hope you have realized your mistake. You're putting x is equal to 120. You're substituting x is equal to 120. So it's basically 4 into 120. It's 480. Now, what if you put x is equal to 100? What if you put x is equal to 100? So this expression is going to give you 480 in this case. This expression in this case is going to give you 400. So that's the whole idea about expressions, right? When you have something varying, okay, you can always use expression because the variable can take different values. That's the whole idea. Unlike a number which is fixed forever, these expressions can vary. That is the power of, no pun intended, that is the power of these algebraic expressions. Cool? Yeah. And you can have, you can also evaluate the expressions in two variables. Say, for example, x plus y. What is the value of x plus y when x is equal to 10, y is equal to 4? See, this is just a quick recap, okay? Because somebody was telling me that they wanted a quick recap before we jump into problems. So we're just giving you a quick recap. Yeah. So what is the answer? When x is equal to 10, y is equal to 4, x plus y is nothing but just plug in the values. That's all. You just substitute x is equal to 10, y is equal to 4. This is nothing but 10 plus 4, which is 14, right? Cool. And the next idea is about simplifying expressions. So we talked about expressions, type of expressions. Then we talked about evaluating an expression. Now it's about simplifying expressions. For that, you need to know what are like terms. What are like terms? Okay. Say, for example, you have an expression 5x. You have an expression 4x plus 7. Just like you add numbers, you can always add subtraction. You can always add the expressions as well. Say, what do you get if you add these two expressions? 5x plus 4x plus 7. What do you get if you add these two expressions? Now, here you have to look at identical variable parts. So in this expression, see, in this expression, this is what we call a term. This is a term. This is another term. Okay. In fact, this is called a constant term. This is called a constant term. And here, this 4 is called the coefficient of x. Right? So this is one expression. This is another expression. And how can you simplify these two expressions? How can you get the sum of these two expressions? This is done by combining the like terms. So what do you think are the like terms in this expression? What are the like terms? What are the like terms? Or the identical terms? Yeah, 5x and 4x, right? So you can simply combine them. 5x and 4x will be nothing but 5x and 4x will be nothing but 9x. 5x plus 4x. Okay, I'm going to use the distributive property. If I take x outside, it will be 5 plus 4 times x, which is 9x. Right? Just like you can do this math, 5 into 10 plus 4 into 10, that is 50 plus 40 is simply 90, right? Is this all right? Cool. Robin, is there any confusion? Yeah. Okay, then quickly tell me, what is this expression? 4n minus 7 minus n plus 9. Can you simplify this expression? Can you simplify this expression? Four n minus 7 minus n plus 9. Oh, that's very good. So you just combine the identical terms. So we have expressions, you have terms having n here, and you have constant terms here. So we have 4n minus n. You just combine them, that is 3n. The other ones are 9 minus 7, that is 2. So ultimately you have 3n plus 2. That is very good. Cool. Okay, let's quickly solve one question. Yeah. We have already seen this question in the last class, but now that you have better idea, can you quickly tell me this question? Quickly tell me the answer. Yeah. The answer is everyone. I want the answer from everyone. Yeah. See, the point I want to highlight here is this question actually came in the calculator section. Okay. Now, what happened if you actually pick up the calculator? What happens if you actually pick up the calculator? You're going to waste time, right? You waste time. So that is the tricky part here. Okay. The tricky thing is, this is a very easy question, very simple question. This is a trivial question, right? Anybody can do it. But this question will appear in the calculator section of the exam. Now, you might, during the exam, you might think that, oh, I need to use calculator for this. Okay, you're going to end up wasting your time, right? So remember that majority of the questions, even in the calculator section, you don't need calculator. If you pick up the calculator, you're going to waste the time. Okay, we'll be discussing all these ideas, these strategies in the due course. And another thing I want to tell you is, see, what if you evaluate these two expressions separately, say 20 into 4 minus 15 into 4. What happens this way if you do it this way? And what happens if you do it this way? 15s minus 20s minus 15s is just 5s. So which is 5 into 4. This is one way to do this. Another way to do this is you plug in the values of s into terms separately. What happens? See the number of operations you need to do. You need to do 2 substitutions. You need to do 2 multiplications. Okay. And then you need to do 1 subtraction. Altogether, you have to do 5 tasks. Got it? But if you can immediately write this 20s minus 15s as 5s, you're just doing 1 subtraction, 1 substitution, and 1 multiplication. Is that all right? But it's all mental math. You don't have to actually pick up your pen or paper or calculator or anything. Right? I mean, this is just trivial stuff, but I'm just explaining because, you have to take care of these kind of things during an exam because, it's about saving each second. Every second matters in an exam. on an average, you get only about 80 seconds to crack a question. So there will be questions which will take more than 80 seconds for sure. So for example, there will be questions which will take 3 minutes to crack. So how do you get 3 minutes to solve a question? You have to save a lot of time on these kind of questions, right? Even if you can save 5 seconds out of this question, it's worth it. I hope this is clear. Yes. Yeah. Okay. Now let's move on to what we call equations. So do not confuse expressions with equations. Now we move on to equations. So equations are basically a mathematical sentence or mathematical statements, okay, by placing an equality between two expressions, right? Say for example, x plus 6 is equal to 2x plus 3. This is an equation. And on the left hand side and right hand side of the equality sign, you have expressions, right? Another example is x plus 6 is equal to 9. Another example may be x plus 6 is equal to 0. Okay. Another example may be x square plus 2x plus 5 is equal to 3x plus 2. Right? So, just like we classified expressions, we can also classify equations. So, these are all equations in just one variable, and the variable being x. These are equations in one variable. Okay. And what do you think will be the difference between these kind of equations and this kind of equation? Can you tell me? Yeah, the first ones are what we call linear equations, because the highest power of x that is occurring in the equation is x power 1. So we call it a linear equation. And here, what do we call this equation? What do we call this equation? Yeah, we call it a quadratic equation, because the highest power of x that occur in the equation is a second degree, an x squared term. So this is called a quadratic equation. Yeah, is this all right? Is this okay for everyone? Yes. You can have equations in more variables. For example, you can have 2x plus 3y is equal to 5y plus 2x plus 7. This is another equation. Can you classify this equation as a linear, quadratic, cubic? What is this equation? This is a linear equation. And what about the number of variables? It has two variables. It has two variables, x and y. Cool. Now let's talk about the solution of an equation or solving for an equation. Solution of an equation. Okay. So what do you call a solution of equation? Can somebody tell me what is a solution? What do you think is called the solution of an equation? Can somebody give me an idea? What do you think is a solution to an equation is? Yeah, you can roughly say it's the answer or a number for the unknown variable x or whatever. Okay, a value or a number that can be given for the variable, okay, which when substituted back instead of the variable will satisfy the given equation, will make the given equation a true statement. Say for example, If I have x plus 3 is equal to 7, if you have x plus 3 is equal to 7, you know that this statement will be true only when x is equal to 4. Right? Right? This is what we call a solution. A solution of an equation with a variable is a number or a value that produces a true statement when it is substituted for the variable. Is that all right? Yeah. So the process of finding the solution is what we call solving an equation. Okay. In this case, we have just one variable. Again, you have to always look for the number of variables. Okay. That is the major thing. Okay. That is a very essential thing about solving an equation. You have to always look out for the number of variables. Okay. You need to distinguish between the variables in the equation and the other numbers, the regular numbers, or just the numbers. Okay. Right. So what about this? We have x squared is equal to 4. What do you think will be the solution to this equation? X squared is equal to 4. Uh-huh. Is it just 2? Is it just 2? Is it just 2? Yeah, minus 2 is also possible, right? Yeah, minus 2. I hope you have already learned about this. Minus 2 whole square is also 4. 2 square is also 4. Yes, Robin, what about you? You square 2, you get 4. You square minus 2, you get 4. So the solutions are x is equal to 2 and minus 2. So we have two solutions here. We have two solutions here, right? So an equation can have one solution. It can have more than one solution. And an equation can have no solution. For example, if somebody tells you that x plus 3 is equal to x plus 5, what happens to this? X plus 3 is equal to x plus 5. What happens to this equation? What do you think will be the solution to this equation? What do you think will be no solution? Because you can't find a value of x. Can you think of some value which is going to satisfy this condition, which is going to make the statement true? Absolutely not. Right? What about others? Is this obvious? Yes, it's obvious because whatever value of x you're going to substitute, it is. So just because you have an equation, it does not mean that it is solvable. Does not mean that it is going to produce a solution. Okay. So always keep that in mind. So when you encounter an equation, you have to clearly have an idea about the number of variables. Okay. The second thing is you have to always look out for the number of solutions it can have. Okay. Of course, in most of the cases, you can figure that out only after solving the equation. Okay. But in some cases, I'll tell you how to figure out the number of solutions without actually solving the equation. Okay. Another example is if I tell you x plus 3 is equal to x plus 3. X plus 3 equal to x plus 3. X plus 3 is equal to x plus 3. What do you think will be the solution? What do you think will be the value of x? See, you can substitute any value for x and still the equation will be a true statement, right? This will always be a true statement, irrespective of the value of x you put, irrespective of the value substitute for x in this expression. This will always be a true statement. Okay, so you can put x is equal to 1. It's true. Put x is equal to 2. X is equal to 3. Okay. So in this case, we say that it has infinite solution, or we say it has infinitely many solutions. Is this all right? Yeah, cool. Yeah. So we have learned about expressions. From expressions, we have moved on to equations, right? An equation will always involve an equality, and on either side, there will be an expression, right? Now, we will be finding the ways to solve an equation, how to solve an equation. And right now, we will be talking about linear equations, and that too in one variable. Okay, so we're going to discuss about the simplest of the equations that you will ever encounter. Okay, this is the easiest stuff. Okay, and of course, these are the most frequent ones that you will encounter, right? So we are going to talk about linear equations in just one variable. Okay, so let's go step by step. So let's try to see the simplest equation. So solving an equation using addition or subtraction. The simplest case. Okay, I'm going to give you the simplest case. Say, for example, you have x plus 9 is equal to minus 3. What do you think will be the solution in this case? X plus 9 is equal to minus 3. What do you think will be the solution? No, don't jump to conclusions, because even though you are supposed to do it in a few seconds, you are also supposed to get it right. Okay, there's no point in getting the answer in a few seconds if the answer is wrong. Okay, cool. Okay, you see, in math it is always about accuracy, right? See, because in English, say if I write this, you can quickly figure out what is wrong with this word or this expression. You can quickly tell what is wrong with this expression, right? Right? Yeah. But in mathematics, it's not so. Even if you make the slightest of the mistake, even if you miss a negative sign, you are going to get the wrong answer, and it will be difficult to figure out where you made a mistake. So always be careful. Okay, always be careful, and always, you need a lot of practice. See, mastering mathematics is about, there are 3 steps. I always tell my students there are 3 steps. It's LUP. Okay, you love math. Okay, then you understand stuff, understand why it happens, and then you practice a lot. Okay, love math. Why should you love math? Not because somebody's telling you that, oh, you're going to need all this stuff. You're going to need all this stuff when you grow up. It's not the reason to love math. Okay, you love math because of the excitement you get from doing math problems. Okay, I want you to love math for the excitement, for the entertainment, for the fun part, right? Not because of its usefulness. Suppose if you try to love math, thinking about its usefulness, it is going to be a difficult situation, because currently you're not able to, as high school children, you may not be in a position to figure out, when am I going to use this? Why am I going to use this? Why am I doing all this stuff? Why am I going through all these drills? You must be wondering. Okay. So nobody can give you a satisfactory explanation for that. So the better strategy is to love math just for the excitement part. Okay. The excitement you get from solving a problem, actually doing it on your own, right? And the second thing is, you have to understand math. You should not blindly mug up stuff. You should not blindly buy hard stuff. You have to understand why it works. Okay. See, math is essentially training of your mind and your logic. Okay. It's basically training for your logical skills. So everything makes sense. You don't have to blindly mug up things in mathematics. Okay. You may have to memorize a lot of things in other subjects. Even in other science subjects, you have to memorize a lot of things. But in mathematics, you don't have to memorize anything, because everything has a logic. And the third thing is, see, ultimately, it's about being able to solve problems. Okay. But unfortunately, your school exams, your this SAT exam, all have time constraints. Okay. So you should be able to do them in short time. So for that, you need a lot of practice. Secondly, as I just mentioned, even if you make the slightest of the mistake, it is very difficult to diagnose where you made that mistake. Okay. So as far as possible, you should be able to do math without making silly mistakes. For that, you need a lot of practice. See, it is possible. With a lot of practice, it's possible. Okay. And for practice, the first step is you should be loving math. Not because somebody told you that you're going to use this later in your life. That doesn't make sense. Okay. For you, for the time being. Of course, math has a lot of uses later on, and you don't have to worry about it for the time being. You just love math for the fun part. Okay. Just like you play a game, you play a sport. Just like you play a sport. Why do you play a sport? Even if you're not planning to take up a professional career in that sport, you'll still play a sport, right? You'll still play a game, right? Why? For the fun part, right? For the excitement. And it is also giving you, it will make your body fit. It will make you physically fit. Similarly, mathematics is the training for your mind. Just like your sports and games are training for your body. Okay. Mathematics is a training for your mind. Okay. It will make you sharper. You will be able to think faster. Okay. You will be able to do mental calculations. You'll be able to understand the world in a better way. Right. See, I am an engineer by training. I have a bachelor's and master's in electrical engineering. I quit my engineer job and came to teaching because I love math. Okay. So the thing is, the whole idea about mathematics is you don't have to actually memorize stuff, because everything can be understood from the basic principles. Yeah, cool. Anyway, coming back, I'm sorry, we digressed. So x plus 9 is equal to minus 3. How do you solve this question? To an inequality, you can add equal quantities on both sides. Okay. So you have to get rid of 9, or you have to isolate x. To isolate x, you have to get rid of 9. So you add 9 on both sides. So you have, what do you have here? X is equal to minus 12. But I hope you can do this question without actually writing this step, right? You can skip this step, right? Cool. This step is not necessary. So tell me this. if you have an expression of the form x plus a equal to b, what do you think will be the solution? X plus a equal to b, what do you think will be the solution? A and b are numbers, but those numbers are not known. Okay, you can, these are constants, but these actual values are not given. What do you think will be the solution for this equation? X plus a equal to b? Yeah, cool. Robin, are you able to figure out this stuff? How can you get the value of x? Yeah, so x will be nothing but b minus a, right? So these are the simplest kind of linear equations in one variable. As I told you, linear equations in one variable are the simplest kind of equations you will ever encounter. And we are talking about the simplest case of the linear equations. We want to go in a step-by-step manner. Okay, so that's why I'm giving you the simplest examples. And you can have you can solve equations using multiplication and division. So solving using multiplication and division. Let's see how this can be done. Okay, can I take 5 more minutes? May I take 5 more minutes? This time is running out very fast. Is it okay if I take 5 more minutes? Cool, thank you. Yeah. So let's say we have an expression of the form minus 6x is equal to 48. Minus 6x is equal to 48. So our job is to find x. You have to isolate x. You have to get rid of minus 6. So how do you get rid of minus 6? You divide throughout with minus 6, right? So what do you think the answer will be? What do you think the answer will be? Yes, that is cool. So you just divide throughout with minus 6. So minus 6x by minus 6 is going to be 48 divided by minus 6. So the answer is going to be x is equal to, what do you got? Yeah, minus h. That's cool. What about an equation of the form x by 3 is equal to 12? What do you think? What do you think will be the solution to this equation? Yeah, that is cool. Robin? Yeah, cool. That is 36. See, if you're stuck, do let me know, okay? See, the problem is, first problem is I've never taught you before. I don't know where you stand currently. I don't know how much of your pre-algebra, how much of your 8th grade, 9th grade stuff you remember. That is one problem. Secondly, unfortunately, we are going through difficult times. And I mean, see, the entire teaching has transformed completely into an online mode. You know, I'm not able to see your faces. I'm not able to see your expression, facial expressions. Typically, a teacher can figure out by looking at your face whether you understood or not. I can't see your workbook. Okay, so do let me know. Do let me know when you're struggling. Okay, no problem with that. Now, so quickly, if I have ax plus is equal to b, what do you think will be the solution to x? If we have ax is equal to b, what do you think will be the solution? Yeah, your x will be b divided by a. That's cool. Yeah. What if we have x by a equal to b, what do you think will be the solution to x? Yeah, your x will be ab. Cool. Okay. So let's quickly see one actual SAT problem. Let's see an actual SAT problem. $176. That's what I'm looking for. Yeah. So this question is a non-calculator question. Even it appears on a calculator section, you're not supposed to pick up your calculator. If you pick up your calculator, you're going to end up wasting your time. Okay, that's very quick. That's very cool. We have 3r is equal to 18. Yeah. From this, we have r is equal to 6. So that is the first step. And now we have to evaluate 6r plus 3. So that is going to be 6 into 6 plus 3. So that will be 39. And our answer is ready. Cool, cool, everyone. Great. Now let's go to the next question quickly. These are all actual problems, okay? These are not cooked up problems. These are actual problems from actual exams. So these kind of questions do appear for the exam. Just that you have to do it quickly. Interestingly, this question is from the calculator part. This question is from calculator part, but if you pick up the calculator, boom, you're gonna waste a lot of time. Yeah, see, Robin, in this case, even if you see two variables, you don't have to worry about that because you can consider this entire C plus D as one number. Consider this entire thing as one single number because, ultimately, question talks about C plus D only. Right? Right? You don't have to worry about the number. There are two numbers, don't worry about it because, ultimately they're talking about C plus D only. So it's easy again. So the answer is 5 by 3. Just one more question and we'll wind up. Yeah. Again, this question is from calculator section. I don't think you need to pick up calculator to do this question. Yeah. So this is 3 by 5 times W is equal to 4 by 3. Okay. How to get rid of that 3 by 5? You have to divide the entire expression by 3 by 5. So W becomes 4 by 3 divided by 3 by 5. So the 3 by 5 in the denominator goes as 5 divided by 3. So that is nothing but 20 divided by 9. Cool. So far, so good, right? So in this class, we discussed the simplest stuff and we saw equations having just one step. One step. That was either you have addition or just multiplication. You have addition or subtraction. And other question we saw we had just multiplication or division, right? In the next class, we'll see more complicated equation, but we'll still restrict our discussion to linear equations. Okay, because now this part itself has a lot of questions, lot of variety of questions. A variety of questions will come. These are the easiest one. Next class, we'll see multi-step equations, where you have to simplify an expression. There will be expressions on both LHS and RHS, where you have to use both addition, subtraction, or multiplication, division. So all this will be involved.